Welcome to Wave Clinical Support. I see from your case you have an advanced keratoconus patient that you're struggling with a little bit, going from a smaller diameter rigid lens, gas perm lens, to a semi-scleral lens that you've been working on. And I see you've had some trouble with trapping bubbles and some bearing and some edge lift. I do want to thank you for sending the images. The slit lamp photos, those were very helpful. And if we look, hopefully we can give you some ideas how to work with this case. These can be very challenging cases. I've worked with a couple of these in my own practice, and we find that the rules tend to go out the window. And the first thing we tend to struggle with these topographies, as you know, we get some data right in through here, but because that cone is so steep, you really lose a lot of data out here in the peripheral part of the cornea. So we're really relying on the wave extrapolation. The problem is if you've got hardly any data out here, for example, in this area, wave is going to probably make some inherent mistakes in interpreting that cornea because it's going to extrapolate off through here. You get some better data up in these areas, and these are almost impossible to get around because that cone is so steep. And so with that said, when we're looking at this case, there's a couple options. One thought is, depending on how small your other lens was, I found in a couple of cases in my own practice that although the semi-scleral was a nice design, I almost found myself staying with a corneal fit, just going to a larger diameter corneal fit. Because it's when you get up here in the sclera, you get the kind of arcing over here. And I know in your lenses you had quite a bit of fluorescein pooling out here through the outer areas and some bubbles being trapped. And if we think about this, remember this is kind of that mountain peak. You've got the lens landing zone out here, you got the mountain peak up here, so you got this big area to traverse, and through here that cornea drops off quite a bit, so you got this kind of gap between the lenses is probably going to fill up with fluorescein and tend to collect some air bubbles down there also. So with that said, how can we get this lens to fit a little bit more cleanly? Well, in this particular case, since you don't have a whole lot of peripheral data out here, I see why you chose freeform, and most cases I would probably do that. This one is not too far inferiorly displaced, so I might be inclined to try to use some of this data up here to my advantage, and probably, at least in this right one, try to go with more of a G-SIM design, hoping that the wave will interpret this area and bring it down over here to hopefully get a little truer representation of that cornea. And then what I would also probably try to do, we got a lot of data in through, so I'd probably really try to match this area very closely, and then hopefully we can map out from there afterward. So if we look at your designs, based on the data that you have to work with, these actually look pretty good. You've got some area edge lift over here that's probably causing, in this area up here, causing some of those problems that you have out on the edge of the lens. So I'd like to see if we can get that to line up a little bit closer. So what I did is I put together a design here, and what I did is I went back to the wave 8-point step. I don't know if you're familiar with that. I'll email you the website for it. But it's a nice little tool for designing these semi-scleral lenses. Steve Codger put that together, Dr. Codger. So if we look at this right here, if we look at this cornea, this topography, I'm going to try to get that zone a little bit more closely in here. So I actually brought it down the size of that a little bit here from where I tried to bring it closer into maybe in that 5, and then the second zone I put it about 7, maybe about in that area, more or less, just because I want to leave enough room for this landing area out here. And then I went over here to this nice little design tool. If you're familiar with the configuration settings, I set my diameter 14, set this at 5 and about 7/10. I set my edge thickness, center thickness, axial, and I decided to go in G-SIM. Once again, you can do it in freeform, but again, in this particular design, we're missing a little bit of the data, so I'd probably do this in G-SIM. In your left eye, we'll talk about that in a moment, but the left lens, that cone tends to be a little bit more decentered inferiorly, so that one you could do the same thing but in free form. So with that said, I went through and designed this lens. I'm just going to cancel it here since I already designed it. Using that 8-point step, I just followed all the steps to it, and you'll see that we got a lens now that is a little bit more aligned. I'm assuming we got a little bit better data now in the superior and inferior area, and this lens I would anticipate would probably center a little bit more nicely for you, and or not necessarily center more nicely, but align more nicely in that cornea. Hopefully a little bit more stable result with that lens and less trapping the air bubbles. I think air bubbles aren't going to be inherent in this lens because you got such a central mountain peak, and it gets so flat out here, so you get this inherent gap in through here, so you have a little trouble with trapping bubbles. So in that case, if it still continues to be an issue, you may want to drop down to more like a on-cornea fit, maybe more like a 10-0, depending how small your other lens was. Maybe go a little larger than that, keeping it in the cornea, and that may give you a little better chance of matching these areas. Keep in mind this peripheral area is landing out here on the sclera. Go back here to your picture. The peripheral curve is landing out here in the sclera, and then you're going to have kind of a flatter area that lands in here. It's going to vault over this area, then land in this cornea in the top, leaving this bit of a gap out here. It collects bubbles. So I would probably use a similar design on the left lens, more the free form. And I would encourage you, if you haven't seen it, go to the Wave training site. I'll definitely include that link in the email. And there's some good examples of some central cones, and also there's a good example of an inferior displaced cone using the freeform design tool and this configuration setting design. And I find that very, very helpful to get you back on track with that. With that, I wish you well with this case, and thank you for contacting Wave Clinical Support. Have a great day.